प्रणाम। रितेश नमस्कार। गणेश चंद्र भाई प्रणाम। नमस्कार। सत्यजित ट्यूशन or tomorrow there is tuition. Okay. रघुनाथ पाड़ी जसकुंतले कौन टाइफॉइड No, sorry, there was no network problem. Actually, someone called me. So that is why I have faced some problem. Alok, you are plus 3 or plus 2? Okay. There is poor network due to rain. Now it is raining or not? Ganesh Chandra Parekh. All are saying that there is network problem. Then tell me what is your opinion? Whether to cancel the live class or to continue? Hello, please reply. Whether to continue the live class or today I will cancel. So Vasilkar is saying that class should not be cancelled, sir. Saswati Manja is saying that we should wait for some minutes. Okay. Okay, in Dhenkanal there is no network issue. That means outside Dhenkanal town there is issue. Okay, wait for only 2 minutes, then I will start. Monosor pronoun. Just wondering, no network problem here, sir. Okay, see here. Now, good evening everybody, and today I will teach you about integrating factor, and which is a very important part. And for JEE, in JEE one question will come, and it is a compulsory question in differential equation. And already all of you have known that in postgraduate entrances, that means even if in IIT JAM also, you will face one question, both in physics and mathematics department. Okay, and I have already told you about exact differential equation, and the differential equation is said to be exact if, that means this one, m into dx plus n into dy is equal to 0. This equation is said to be exact if del m by del y is equal to del n by del x. Already I have told you. And if the equation is exact, then its solution is integrate first part m of xy into dx, treating y as constant, and integrate second part only those terms in n not containing x into dy is equal to c. Integrate the first part treating the second variable constant, and then integrate the second term, and you should consider those terms in n which does not contain x is equal to c. This is all about exact differential equation, and question is that if a differential equation is not exact, then how to solve it? If a differential equation is not exact, then how to solve it? Okay, see here. I have told you in derivation in physics or in chemistry or in engineering subjects, the teachers are saying that multiply 2y dash or simply y dash square, multiply both the sides. Why they are saying that in order to multiply x dash or xy or x square or y dash or y double dash y in order to make it exact. And the term which you are multiplying to make it exact is called integrating factor. That means integrating factor is a function which should be multiplied to a differential equation which is not exact will become exact. That means if m of xy into dx plus n of xy into dy is equal to 0 is not an exact differential equation, then integrating factor is a function Integrating factor is a function which when multiplied to equation 1, the left hand side becomes an exact differential. The left hand side becomes an exact differential. Do you understand or not? Integrating factor is a function which when multiplied to equation 1, the left hand side will become an exact differential. Clear? Now, question is that how many integrating factors are there for a differential equation? Infinite. There are infinite number of integrating factors for a differential equation. That means a differential equation has infinite number of integrating factors. Okay. Now, for example, see here, x into dy minus y into dx is equal to 0. Clear? So, this is not an exact differential equation. Now, what will be the integrating factor? Here, if I multiply 1 by x square, then it will become x into dy minus y into dx divided by x square equal to 0. So, which is derivative of y by x equal to 0. Now, it becomes an exact differential equation. That means 1 by x square is an integrating factor. 1 by x square is an integrating factor. Another integrating factor is 1 by xy. If we multiply 1 by x square to this equation, it will become dy by y minus dx by x equal to 0. Clear? And this is derivative of ln of y by x equal to 0. Clear? So, this single equation I have given two integrating factors. One is 1 by x square, another is 1 by x square. So, integrating factor may deviate, but the solution remains same. Okay. Now, I am going to tell you some rules how to find out the integrating factors. That means that will not help for each and every equation to find the integrating factor. For particular cases, there will be 4 types, and if the differential equation are in these 4 forms, then you can say the integrating factor. But while facing the problems in entrance examinations, I will tell you the trick how to find out the integrating factor within 1 minute. Okay, because integrating factor is infinite for the differential equation, so you cannot apply the procedure, and the procedure is limited to only 4 types. They are applicable to 4 types of differential equations, and beyond that you cannot say. By method of inspection you have to find out, and practically it is difficult by method of inspection. Okay, see here, the equation is like this: m of xy dx plus n of xy dy equal to 0. This is equation 1. So see here, theorem 1. That means rule 1. If equation 1 is a homogeneous differential equation, then integrating factor will be 1 by mx plus ny. Condition is that mx plus ny must be unequal to 0 because p by q, and q must be unequal to 0. M into x plus n into y, and 1 by this one is the integrating factor. So let us take an example. I am giving an example of this type, then we will proceed. See here, x square y minus 2x y square into dx plus 3x square y minus x cube into dy is equal to 0. So how to find out the integrating factor? By theorem 1. First of all, what is the degree of this term? 3. 2 plus 1 3. Here 2 plus 1 is 3. Here 2 plus 1 is 3. Here is also 3. So the degree of each term is same. That means this is a homogeneous differential equation. And here m is equal to how much? This one. The function which is attached with dx. X square y minus 2xy square. And n is equal to 3x square y minus x cube. And what is your integrative factor? Integrative factor is equal to 1 by mx plus ny. So this is your equation 1. So it's equal to 1 by mx, m into x. So multiply x here. That means x cube y minus 2 x square y square plus n into y. So multiply y into this one. 3 x square y square minus x cube y. So plus x cube y minus x cube y cancel out. So 3x square y square minus 2x square y square, it is equal to 1 by x square y square. So this is the integrating factor. And what is your definition? Your definition is that if the integrating factor is multiplied to the given equation, then the given equation will become an exact differential equation. That means multiply 1 by x square y square to equation 1, automatically the equation will become exact. Equation 1 will become an exact differential equation. So you need not to check the equation whether it becomes an exact or not. By definition, if you multiply the integrating factor, then automatically it will become an exact differential equation. So write it. Multiplying 1 by x square y square to equation 1, we get it will become 1 by y minus 2 by x into dx plus 3 by y minus x by y square into dy equal to 0, which is directly you should write, which is an exact differential equation. Therefore, solution is first part, you have to integrate first part into dx, treating y as constant, and plus second terms not containing x in n into dy equal to c. So here y, that means directly you can write also here. You should write the terms in which x is not present. This term contains x, so omit this one, only 3 by y. So 3 by y into dy is equal to c. So here y is constant, that means 1 by y goes outside, integration of dx is x, minus 2 dx by x, it is ln x, plus 3 dy by y, it is ln y, is equal to c. So this is your answer. Then you can cross multiply y also. Here, that means first find out the integrating factor, then multiply the integrating factor to the given equation, so it will become exact, then write the solution by exact differential method. Okay, because it will become exact on multiplying. So now let us come to theorem 2. Before that, I want to tell you something. What is f of xy like this and f of xy like this? This is a function of x and y. This is a function of x and y because comma is there. And this is a function of xy. This is a function of xy, but this is a function of x and y. So here you can write like this: x square y plus x plus y. Like this also you can write. This is a function of x and y. But here xy whole square 3xy plus 5. Because if I take xy as t, then it becomes t square plus 3t plus 5. So this one is a function of xy, not function of x and y. This is a function of xy. Okay, see here. Now, if equation 1 can be written as function of xy, don't say x and y, function of xy into y dx plus function of xy into x dy equal to 0, then integrating factor 1 by mx minus ny. Condition is that mx minus ny is unequal to 0, because this is in the form of p by q and q must be unequal to 0. Clear? Remember, function of xy into y dx and function of xy into x dy. The given equation should be in this form, equal to 0. Then the integrating factor will be 1 by mx minus ny. Clear? See, here I am giving an example. X square y square plus xy plus 1 into y dx plus x square y square minus xy plus 1 into x dy equal to 0. See here. This is function of xy. I have already told you. Because xy whole square, it is xy to the 1, here xy to the power 0. This is a function of xy into y dx. This is also a function of xy. Function of xy into x dy equal to 0. This is in the form of theorem 2. Because in the theorem 2, I have told you f1 into f1 of xy, that means function of xy into y dx plus function of xy into x dy. Then, what is your m here? M is this one, including y. Clear? So integrating factor is 1 by mx minus ny. This is your m and this is your n. Clear? So mx minus ny. See here, m into x. So this one into x, that means the outside term will become xy. So multiply xy to these three terms. It will become x cube y cube plus x square y square plus xy minus n into y, that means this x will be multiplied with y, then xy should be multiplied to each of these three terms. It will become x cube y cube minus x square y square plus xy. Clear? So open the bracket. X cube y cube cancel out. xy cancel out. Only this one. That means 2 x square y square. Now this is equation 1. Now what is the definition? You should multiply 1 by 2 x square y square to the given equation so that it will become exact. Clear? See here. Multiplying 1 by 2 x square y square to equation 1, we get x square y square cancel out, 1 by 2 and multiply y also, y by 2 plus multiplying y square also cancel out, so x also cancel out, 1 by 2x plus then remain 1, that means y cancel out, 1 by 2 x square y into dx plus x square y also cancel out, x by 2 minus x square cancel out, 1 by 2y plus 1 by 2 y square x into dy equal to 0, which is an exact differential equation. Clear? Now solution is, what is your solution? First part integrate plus 1 by 2x square y into dx, taking y as constant. And second term, only those terms independent of x. Here there is x, here there is x, only this term. So minus 1 by 2y into dy equal to c. So now you can do this one. Y is concerned with y by 2 goes outside, integration of dx is x. Here 1 by 2 goes outside, 1 by x dx is ln x. Here 1 by 2y goes outside, x to the minus 2 dx. You can integrate this one. And this is here 1 by 2 ln y is equal to c. You can do this one. Okay. So let us see another theorem. And I am going to tell you two important theorems now. And for BTech students is very important. The theorem 3 and theorem 4. And in some books, theorem 1 and 2 are not there, only theorem 3 and 4 are there. Clear? Theorem 3. If del m by del y minus del n by del x whole divided by n is equal to f of x, then indicative factor is equal to e to the power integration f of x dx. So this is your indicative factor. And theorem 4, if del m by del y minus del n by del x divided by capital M is equal to f of y, then indicative factor is equal to e to the power minus f of y dy. In the fourth case, you should take your minus outside integration. In the third case, there is no negative sign. Clear? Now, see, the numerator in both the cases are same. Del m by del y minus del m del x, del m by del y minus del m by del x. If you divide n, the result should be a function of x only. There is no y. And if you divide m, the result must be a function of y only. And in some cases, both the theorems satisfy. So you can take this one or this one. Indeed, I have told you, indicative factor may vary, but the answer will remain same. Okay. Now see here, how to test whether you should take this theorem or this theorem. Clear? I will give you an example. And see mindfully how I am applying the theorem. Here, this one is x, this one is m. Here, m is equal to x square plus y square and n is equal to minus 2xy. Not plus 2xy, it is minus 2xy. So, del m by del y, write the numerator. And I don't know what will be the denominator. It is also unknown to you. Finally, you will see whether it will be m or n. Okay, so leave the denominator like that. So del m by del y, it is 2y minus del n by del x with respect to x, that means minus 2y by, later on we will fill up the blank spaces. It will be 2y plus 2y, it is 4y. Now tell me whether you should divide this one or this one. If I divide this one, it will be 4y by x square plus y square. But the right hand side should be either function of x or function of y. But if I divide this one, it is neither a function of x only nor a function of y only. But if I divide this one, y will cancel out, only function of x will remain. And what is n? That means for n, right hand side should be a function of x. Clear? So then write n. It is minus 2xy. It is minus 2xy. So 4 2 cancelled, minus 2, y cancelled, 1 by x. So another point I am going to tell you. See here, e to the power x ln a is equal to a to the power x. already known to you. E to the power x ln a is equal to a to the power x. This x will go to the power a to the power x. This is a property. Clear? In logarithmic. So now integrative factor. What will be the integrative factor? The third one, e to the power integration of f of x dx. E to the power integration f of x. Here f of x is this one. Minus 2 by x into dx. Minus is here. That's why I am taking minus. So minus 2 goes outside. And 1 by x dx is ln x. And apply this trick. It will be a to the power x. It will be x to the power minus 2. Minus 2 will go to the power x to the power minus 2. And x to the power minus 2 is 1 by x square. Clear? So now 1 by x square should be multiplied here. Now multiplying 1 by x square to equation 1, we get 1 plus y square by x square into dx minus 1 by x square, that means 2y by x into dy equal to 0, which is exact. Clear? Now solution is, I have told you, I am directly doing integrate first part treating y as constant. So 1 into dx is x, and the second part y square goes outside, and x to the minus 2 dx, it is minus 1 by x. Clear? And you should consider those terms independent of x. There is no term independent of x, so equal to c. So this is the answer. Clear? Now another example I am going to give you, and very important point. See here. Don't apply theorem 1. Instead, if you apply theorem 3 and 4, it will be better. That means the integrating factor will be a very simplest form. 1 by x, 2 by x, 1 by x square, 2 by x square, like this. So that on multiplying, the question will become very simple. Clear? So avoid applying theorem 1. And for theorem 2, the form is in the direct, the form will be in direct form. And by seeing only you can say that theorem 2 is applicable to this question. Okay. See here. Y dx plus x square y minus x into dy equal to 0. And here m is equal to how much? Y. And n is equal to x square y minus x. And your form is del m by del y minus del n by del x divided by del m by del y, it will be 1 minus del n by del x with respect to x, 2xy minus 1 divided by. Clear? So it will become 1 minus 2xy plus 1 divided by. So 1 plus 1, 2. 2 minus 2xy. So if I take 2 common, it will be 1 minus xy. So here if I take x common or minus x common, 1 minus xy. Clear? From these two, you will take minus x common, it will be 1 minus xy. 1 minus xy is there. So simply take n. It is n. This is also n. And this is minus x into 1 minus xy. So these two cancel out. You will minus 2 by x. And your theorem was, if you divide n, the right hand side must be a function of x. I am dividing n here, and the right hand side is a function of x only. So what is the integrative factor? Integrative factor is e to the power integration of this function minus 2 by x dx is equal to minus 2 and 1 by x dx is ln x and it is x to the minus 2, that means 1 by x square. So if I multiply 1 by x square to this equation, it will become exact. Now you can solve. Okay, see here. Now I am going to give two examples in which the four theorems are not applicable. Clear? So how to do those type of questions? See here, one example I am giving you. X into dy plus y into dx plus 3 x cube y to the 4 dy equal to 0. This part is derivative of xy. See here, if we apply those four theorems, so nothing will be obtained. Theorem 1 is not satisfied here, it is not a homogeneous, and theorem 2 is also not applicable, and 3, 4 is also not applicable. You can test it. So here 3 x cube y 4 dy equal to 0. See here, this is a form with respect to y. You are integrating this one, you have to integrate with respect to y. So y should be there and x should be eliminated. And how to eliminate x? By dividing x cube. Clear? But here you can divide x cube, but here you cannot divide simply x cube because xy is a single variable. If I take xy as t, this is in the form of dt. Clear? So you cannot divide x cube only because x and y are a single variable. So you can divide x cube y cube so that it will become t cube. So here derivative xy divided by xy whole cube, that means x cube y cube I am dividing. So 3y dy. Now it becomes exact differential equation because it is direct integrable dt by t cube. This is also direct integrable y dy is y square by 2. So here I can write integrated factor is equal to 1 by x cube y cube. So here integrating dt by t cube, it is in the form of dt by t cube. See here dt by t cube, dt to the minus 3 dt and dt to the minus 2 by minus 2. That means minus 1 by 2 t square, t to the minus 2 goes to the denominator. So minus 1 by t, what is t? xy to the power 2 plus 3 y dy is y square by 2. So your 2 is there and is equal to write c by 2, so that you can cancel out 2, then you will get the result. Clear? Now another question, and this is by inspection I have done. Another question simply by inspection. See here, x into dx plus y into dy plus x square plus y square into x square into dx is equal to 0. See here, this one you can integrate. The equation is x square by 2. This one also you can integrate, but this part is not integrable. But you are doing with respect to x, so y part should be eliminated. That means this part should be eliminated. This is a single term. This part should be eliminated. How? By dividing x square plus y square. And if we divide x square plus y square to this one, we can do, because the derivative of this one is 2x dx, 2x dx and 2y dy. Clear? So here I can do like this, x dx plus y dy divided by x square plus y square plus x square into dx equal to 0. So here integrative factor is, here integrative factor is 1 by x square plus y square, because by multiplying 1 by x square y square it is integrable. I am dividing 2 and multiplying 2, 2x dx plus 2y dy divided by x square plus y square plus x square dx equal to 0. Now integrating, derivative denominator is here. So dt by t, that means ln of x square plus y square plus this is x cube by 3 is equal to c by 2. So cancel out 2 and take c to left hand side. Ln x square plus y square and take it, it will be better half ln c. I am taking because the constant anything can be taken as the constant. You can take ln c or tan inverse c or sin c or c by 2 or 2c, anything according to your suitability. Clear? So this is 2 by 3 x cube. I am taking this term to right hand side and this one to left hand side. Minus ln c is equal to minus 2 by 3 x cube. So ln by 3 x cube. So it implies x square plus y square by c is equal to e to the power minus 2 by 3 x cube and multiply c to right hand side. X square plus y square is equal to c into e to the minus 2 by 3 x cube. So this is the answer. Clear? So it is not necessary that in each and every problem the four theorems will be applicable. In some cases it is applicable and in some cases it is not applicable. But how to solve the questions in the examination, that means in the competitive exams, in JEE or in PG entrance, how to solve it. See here, the question will be like this. And your question will be like this: indeed factor is equal to dash. Okay. I have done this question perhaps. Del m by del y, that means 2y minus del m by del x minus 2y plus 2y, that means 4y divided by minus 2xy. It is y cancel out, then minus 2 by x. Then integration will be minus 2 ln x, minus 2. Let's see here. Let's see. In the big one, it will be 1 by xy. In big 2, it will be 1 by x square. In bit 3 it will be 1 by y square. In bit 4 it will be 2 by x. Like this. The options will be like this. So, but since the differential equation has infinite number of iterative factors, you cannot go from the question. You should check from the options. Always in 100 cases, 100% cases. That means multiply 1 by xy to this equation. What you will get? See here, if you multiply 1 by xy, it will be x by y minus y by x into dx minus 2 into dy equal to 0. And what is your formula? Derivative of this one with respect to y. So, find the derivative of this one with respect to y. It is minus x by y square. Because x is constant, derivative of 1 by y is minus 1 by y square, and this is minus 1 by x. And what is the derivative of this one? With respect to x, it is 0. So both are unequal. So this one is not the integrative factor. How many seconds I have taken? Only 5 to 6 seconds. Clear? And for 1 by x square, you will multiply. I am testing this one first. 1 by y square. It will be x square by y square minus plus 1 into dx minus 2x by y into dy equal to 0. So derivative of this one with respect to y. So y to the minus 2 minus x square by y. Y cube it is minus 2, and derivative 1 is 0, and this one is with respect to x, so minus 2 by y. So both are unequal, so this is not the integrative factor. Clear? So then multiply 2 by x. Here 2 by x means 2x plus 2y square by x into dx minus 2y into 2, it is 4y into dy equal to 0. So here the derivative this one with respect to y, with respect to y means this one is 0. Clear? And with respect to y means 4y by x, 4y by x, and the derivative this one with respect to x, it is 0. Both are unequal. So the last one is not the integrative factor. Now 1 by x square. So it is 1 plus y square by x square into dx minus 2 y by x into dy equal to 0. Clear? So find the derivative of this one with respect to y. With respect to y means 2y by x square, and here with respect to x it is minus 2y, and derivative 1 by x is minus 1 by x square plus 1 by x square. So both are equal. So this is the integrative factor. Clear? So it will hardly it will take 30 to 40 seconds. You will test all the cases. Okay. Or if there is none of these cases, so I have tested 3 and the last one will be the answer. Clear? So this is all about the integrative factor. And simply while facing the question in the entrance examination, test from the options. Simply multiply the first option to the given question and then test del m by del y or del n by del x. If they are equal, then it is exact, otherwise this is not the integrative factor. Then proceed for other options. Okay. Now I will give some questions on integrative factor in the description box, and try to do those questions. And some tricks I will also give you how to integrate directly. For example, I am writing x dy plus y dx. X dy plus y dx are derivative xy. X dy minus y dx divided by x square. I am writing derivative y by x. Like this, I will give you 10 to 15 formats. If you remember those formats for solving the differential equation, it will be better for you. Okay, in the description box I will give you, and please download those points, and also I will give you some questions and do those questions. Okay, and whether this time is perfect for you or not, please tell me. Hello, this 10 p.m. is perfect or not? Because in the daytime it is raining, and in maximum cases we will face some problems. So that's why I have decided to take the class at 10 p.m. Because at 10 p.m. minimum problems we will face, not maximum, but there will be problem in daytime or in evening hour. We will face problems, and basically network problem. But due to weather, I think 9 p.m. will be better. Okay, all are saying that 10 p.m. is okay. No, I cannot do the live classes in the evening because there is other classes in the evening hour. That means I am taking the 11th class classes, 11 classes and 12 classes in the evening hour from 6 to 9. Clear? That is why I cannot take in the evening hour. But in the afternoon, that means at 4 p.m. or at 5 p.m. I can take, but it is not suitable time because in maximum basis at 5 p.m. it is raining. Okay, thank you, and I hope it will be better. It will be very easy for you to solve the differential equations, and simply remember the four theorems and do the problems. And if you do the problems, then it will be better for you. Okay, and one advice for you that don't miss my classes because I am taking the classes according to your requirements. Okay, so and tomorrow I am going to take the integration class. So the plus 3 students can attend the integration class also. Same time, 10 p.m. also. And if you attend those classes, then it will be better for you to do the differential equation. But because in differential equation, integrations are necessary. Clear? And different techniques also I will tell you, and the formulas also I will give you. Okay, so attend the integration class also. Okay, thank you.